Hi students, how are you all? Now, today I am going to explain one more chapter in the 12th class. Previously we completed the two chapters, electric charges and fields, electrostatic potential and capacitance. Now I am going to start the third chapter, that is current electricity. Right, class 12, third chapter, current electricity. This is the first part in the third chapter. The first part I am indicating like 3.1. Next second part will be 3.2. 3 indicates the chapter number and 3.1 1 is the part 1, right? And like that you have to look at every video in order. Okay, right. And now I am going to start the current electricity. And what is current electricity and what we are going to discuss in this chapter? First of all, I will tell that one. And for that, current electricity discuss about the current. Okay, current means how the current will be generates. What is current electricity? Right, the current electricity is the definition of current electricity is the the branch of physics, right, which deals with the flow of charges. The study of flow of charges is called as the study of flow of charges. The study of flow of charges is called as current electricity. Right, current electricity is what? Study of flow of charges. We are going to discuss about the flow of charges. Right, the study of flow of charges is called as current electricity. And now next I am going to tell what is current, how to define the current. Okay, when we say that the current is passing through a wire, okay, current is denoted with a small I or capital I. Let us see what is the definition of current. Already you learned in the 10th class, right? The definition is the rate of flow of charge is called as current. The rate of flow of charge is called as current. Rate of flow of charge means what? Rate of flow of charge means charge rate. Okay, that means for every second how much charge flows, that is called as electric current. Now the current definition in another way we can also write the amount of charge flows per second. The amount of charge flows per second. The amount of charge flows per second is called as electric current. Okay, is called as electric current. Now what is the formula for the electric current? Now the electric current formula is current is equal to electric current is equal to charge by time. Charge by time. This we can write like this, that is the current I is equal to charge by time. Okay, charge is Q, time is T. This is the formula for the current. But we know the charge is quantized, then we can also write the current formula as I is equal to Q by T, but the charge is quantized. If n electrons flows through the wire, right, then the charge is equal to Ne by T, right? This is also current formula, where N is the number of electrons passing through a wire and E is the charge of electron. Number of electrons and E is the charge of electron. Okay, charge of electron is how much? 1.6 into 10 to the power of minus 19. This is coulomb. Okay, this is the charge of electron. One electron has the charge E. If n electrons flows, the charge become Ne, right? One electron has the charge E. If n electrons flows, then how much charge flows? That is Ne. That means Q is equal to Ne, right? And now this is the current formula. And what is the unit of the current? And what is the direction of the current? Whether the current is a vector or scalar, that we are going to discuss. Okay, the current is SI unit of current. First I will tell SI unit of current. Okay, SI unit of current is ampere, right? today we are discussing some basics, right, that already you learned in the 10th class. Okay, the same thing also there in the 12th class. This is ampere. Okay, ampere or symbol is what? Capital A. Ampere symbol is capital A, right? Capital A. If you want to write the full name, you should write with the small letters, and if the symbol you want to use, only capital letters. SI unit of current is ampere or capital A. And the small current, listen it here, the small current can be measured in microamperes and milliamperes. Let us see what is that small current. Okay, small current measured by the unit milliampere, right? 1 milliampere is equal to how many amperes? Milliampere. 1 milliampere is equal to 10 to the power of minus 3 amperes. We can also write 1 microampere. Okay, microampere, that is 1 nu A, that is 10 to the power of minus 6 amperes. Okay, like this the current other units are milliampere or ampere. Okay, and we can also write one thing, that whether the current is a scalar or vector and what is the direction of the current. And first of all I will tell the direct whether it is a vector or scalar. Current is a scalar, it's not vector. Why it is a scalar? Why it is a scalar? The current has a direction, right? And before that I will tell the direction also. After telling the direction I will tell about whether it is a vector or scalar. For example, this is a wire. What is this? This is a wire, and through that wire how the current will flows? Okay, current flows only in conductors, right? And now for example, I want to know the direction of the current. For that I am taking one wire. This is a wire. In this, for example, this side we connect to the battery positive terminal, and this side we connect to the battery negative terminal. At that moment the electric field will be generates in across the wire. The electric field is from positive to negative. Some electric field we are applying. And now if electrons are there, these electrons, okay, electrons are there in the conductor, that electrons goes left side, because the electrons repelled by this negative and attracted by the positive, they will go from negative to positive. And now the electrons goes this side. And what about the current? The direction of the current we will take as right side. That means the direction of conventional current. The direction of conventional current. Tell me. Direction of conventional current. Direction of conventional current is opposite to the direction of flow of electrons, right? When electrons goes left side, okay, electrons goes left side, but what happening? Current goes right side. Okay, direction of current, conventional current is opposite to the direction of flow of electrons. If you take a small circuit, from the outside of the battery, the current flows from positive terminal of battery to the negative terminal of battery. Let us see and take a screenshot and note it. Now I am going to continue. For this, let us see small circuit. Let us take. In that small circuit, this is a small bulb, okay, and here this is a positive terminal of battery, and this is a negative terminal of battery, and this is a plug key. And now what is the direction of the current? Okay, and now through this bulb, the bulb has the filament, okay, that is a tungsten filament. It has some resistance, high resistance, and now direction of current is from positive terminal to negative terminal. This is the direction of the current, right? That means direction of current in closed circuit, right? The direction of current we can also write like this, that is the current flows from where to where? From positive terminal of battery, to the negative terminal, right? This is outside of battery, okay? This is the case, that is outside of battery. Current flows from where to where? This is outside of battery. Current flows from positive to negative, but electrons flows from negative to positive, and the direction of the current is always taken as opposite to the direction of flow of electrons. And now I am going to tell, we are telling that current has direction, but with current is not vector. Why the current is not a vector? Because current is a scalar. I will tell the reason, wait 1 minute. Current is a scalar because current does not obey the laws of vector addition, okay? Because current does not obey laws of vector addition. Do you know the laws of vector addition? Yes, parallelogram law, triangle law, polygon law. In motion in a plane chapter in the 11th class we discussed that one, okay? Then vector means it's a physical quantity. It has both magnitude and direction. Along with that, it should obey the laws of vector addition, okay? Now vector means what? Vector is a physical quantity which has both magnitude and direction and also obeys the laws of vector addition. But here it will not obey the laws of vector addition. What are the vector additions? For example, this side one force is acting F1 and this side other force is acting F2. Then what is their net force? The net force we cannot write as F1 plus F2, right? You know already. Why? The net force is not equal to sum, because the two forces are not along same direction. In case of vectors, we cannot add directly to get the net force or net physical quantity. Why? Because we have to use the vector laws, right? And according to vectors laws, what is the net force formula? The net force formula is, we write like this, under root of F1 square plus F2 square plus 2 F1 F2 cos theta we will write, right? And F net force we will write like this, under root F1 square plus F2 square plus 2 F1 F2 cos theta. The net force also depends upon the angle, right? That means the net force according to parallelogram law, it is along this direction. If the two forces are acting along the two directions, right, like this, if they are the two adjacent sides of parallelogram, then the resultant is along the diagonal. This is the net force direction, right? The net force not only depends upon the individual forces, it also depends upon the angle between the two forces. In vectors like this, we have to use the parallelogram law or triangle law to find out the resultant force. And now let us see, this current has the direction, but whether it will obey the laws of vector addition or not, let us see. And for that, look at here one diagram I will give, and this side, for example, 5 amperes current is coming, and this side for example 2 ampere current is coming, and after between these two wires there is some angle is there, and this side the wire is going, and then how much current it will flow that side? I1 is equal to 5, I2 is equal to 2. Then practically it is observed that I3 is equal to 7 amperes. Okay, that means here I3 is equal to direct I1 plus I2 we are doing, but we are not taking the angle as account. That means angle is not participating it here to calculate the net current, right? Directly we are adding, that means directly we can add only scalars, okay? That's why here the current does not obey the vector laws. If current obeys the vector laws, the net current should be equal to under root of I1 square plus I2 square plus 2 I1 I2 cos theta. but theta is not there. This side phi is there, this side 2 is there. Two currents will be mixed and goes this side. Only directly we have to add, and we will not use the parallelogram law to find out the total current. That means it will not obey the parallelogram law, right? And whatever it may be the angle, for example like this there, okay, 5 ampere, it will not depends upon the angle. Okay, look at here, like this here, this is the 5 ampere and this is the 2 ampere, and combinedly if it goes this side, and what you will get here, tell me? Right, this side 5 it is coming, this side 2 is coming, though 2 combinedly it will goes this side 7 ampere, right? For example, if the same thing is there in the vectors, this side force for example 7 newtons, and this side force if it is this is 5 newtons and this is 2 newtons, what is the net force at here? To find out the total force we have to subtract it here, but here we are finding the net current just by adding, right? It will not obey the vector laws. According to vector laws, if two vectors are along same direction we can add, if two vectors are opposite direction we will subtract, if two vectors are at certain angle we will use the parallelogram law to find out the net force, right? Let us see here, and the current is a scalar, it does not obey the vector laws. It has the magnitude and direction. Current has certain value, current has certain direction, but even though it does not obey the laws of vector addition. And now let us see current in circular path. I want to find out. Okay, current basic formulas we discussed, what is current and what is its unit, and also I will tell one point that which instrument we will use to measure the current, right? Okay, current measured by an instrument, right? Current measured by, do you know, ammeter, right? Current measured by ammeter, right? And now let us see the current in circular path. The next topic is current in circular path. Current in circular path. Current in circular path. How to find out the current in circular path? Current in circular path. This is our topic. Current in circular path. For example, this is a Q charge. This is a Q charge. This Q charge is moving along a circle like this, and this charge is moving with speed v, and the radius of the circle we will take as, the radius of the circle is small r. Okay, now what is the current in the circular path, right? That I am going to find out. How to find out the current in the circular path? Then the current formula is what? Charge by time, right? And for that I will give little bit information. Okay, a charge Q moves along a circle of radius smaller with speed v. Okay, look at here, this Q charge is moving along a circle with speed v, and the radius of the circle is smaller. Then the current formula we know that the current formula is charge by time. Okay, and but here for one revolution, actually in closed path only current will flows. In closed path current flows. For example, the charge starts at here, and again if it will comes to this point, then we say that it is closed. Okay, then in closed path only current flows. That's why the current is equal to, we write as charge by time, but the time to close the circuit is time taken to complete one revolution. Okay, in one revolution it will become closed circuit. That's why the current formula is charge by time period. We have to take time period. Why we will take? In that time period, capital T, it will complete the one revolution. When it will complete the one revolution, then it will complete the closed path. Closed path completes. Okay, charge by time, where T is the time period. Okay, T is what at here? Time period. What is the time period formula? Time is equal to, we know, distance by speed, right? Distance by speed. We know already speed is equal to distance by time. speed is equal to distance by time. Speed is equal to distance by time. From this, time is equal to distance by speed we write. Okay, look at here. Time is equal to, we have the distance by speed. In one time period means, in time period how much distance it can travel. If it starts from here, in time period it will complete the one revolution. When it will complete the one revolution, then how much distance it can travel? That distance is equal to circumference of the circle. That is 2 pi r by, what is its speed? The speed with which the electron or the charge q is flowing in the circuit, or in the, not in the circuit, in the circular path is v. Okay, with v speed the charge is moving along the circular path. Then the current charge I is equal to q by capital T. What is capital T at here? 2 pi r by v. Right? Then we will get, what you will get here? I is equal qv by 2 pi r. Right? This is the formula for current in circular path. Okay? Current in circular path. But we know in circular path, if you want to write the relation between the linear velocity and angular velocity, but linear velocity v is equal to, in the 11th class we discussed, but the linear velocity v is equal to, we write r omega, right? R omega, where omega is, okay, omega is what at here? Angular velocity. Angular velocity. In circular path, angular velocity will be there, right? R is the radius, v is the linear velocity. And now we write here I is equal to q into v, formula is r omega by 2 pi r. This r will cancel. We can also write the current formula as I is equal to q omega by 2 pi, right? These are the various formulas to find out the current in circular path. And now let us go for the next topic. The next topic is Ohm's law. What is Ohm's law? You know already in the 10th class, right? Let us continue it. And for that, okay, our next topic is Ohm's law. What is Ohm's law? That also we discussed in the 10th class, right? You already know about these all things. Now what is Ohm's law? Right? Ohm's law. Ohm is the name of the scientist. Right? What is Ohm's law? And Ohm's law is very simple. You know very well. At constant temperature, current through a conductor is directly proportional to the current through the conductor is directly proportional to the, what, tell me? To the potential difference across it or across conductor, right? What you are telling it here? At constant temperature, if temperature is constant, right? If at constant temperature, current through a wire is directly proportional to the potential difference, I proportional to V. When the proportionality is removed, we will get one constant, right? And before this I proportional to V, we can also write as V proportional to I, right? When the proportionality is removed, we will get a constant, that is R, okay? V is equal to IR is the Ohm's law equation, right? What is R at here? R is a proportionality constant, right? Proportionality constant. Its name is, you know very well. What is its name? That is resistance. Now, this is Ohm's law. What is V at here? V is the potential difference. For example, this is a wire. Across this, some current is flowing, I. And across the two ends of the wire, the potential difference is V and the wire resistance is capital R. The relation between them is V is equal to IR. Okay, R is a proportionality constant, that is resistance. Now, some substances, when we increase the potential difference, automatically the current also increases. And now the substances which obeys this Ohm's law are called as ohmic substances. Remember that. Now I am going to tell about the ohmic substances. Ohmic substances. Ohmic substances means these are the substances, they obeys the Ohm's law, right? The substances which obeys the Ohm's law, the substances which are obeys Ohm's law, obeys Ohm's law are called as what? Are called as ohmic substances. Ohmic substances are the substances which obeys the Ohm's law. Example for the ohmic substances which will obeys the Ohm's law, right? The example is all the metals obeys the Ohm's law. Means what happening? Current proportional to the potential difference. Okay, most of the conductors obeys the Ohm's law. Okay, and now let us see metal conductors obeys the Ohm's law. Okay, aluminium, copper, these are the conductors which obeys the Ohm's law. Let us see if they will obey the Ohm's law. If we draw the graph between the potential difference and current, then how you will get, right? If we draw the potential difference between the current, if you draw the graph between the potential difference and current, then how you will get? It is very simple. You know already graphs. I will tell again. For example, the potential difference is taken on x-axis and the current is taken on y-axis, right? And this is IV graph. Okay, IV graph. Let us see how you will get the graph. The graph you will get a straight line, right? If it will obey the Ohm's law for the ohmic substances. Graph is a straight line, and for example this is the theta. Okay, theta is what at here? Theta is angle made by straight line with what? X-axis, right? With x-axis. And now if you find out the slope of IV graph, what it will give? Slope of IV graph or the VI graph. Slope is tan theta, you know already. Or one more formula is there, difference in y coordinate by difference in x coordinate. In the mathematics we know the slope formula, right? The slope formula is one is tan theta and other one is difference in y coordinate by difference in x coordinate. Okay, y2 minus y1 by x2 minus x1. Tan theta equal to opposite side by adjacent side. This opposite side is the, this length gives, it will gives, this length is equal to current y, and this is adjacent side. Adjacent side is the voltage. For example, this is the tan theta I want. If you take this point, right, and tan theta equal to opposite side, current it will gives, and adjacent side it will gives voltage. Means if you find out the tan theta, what it will gives? It will gives the I by y, I by v, right? Tan theta gives the I by v. I by v means what it will gives? According to Ohm's law, I by v is the, v is IR. Okay, IR we write, II cancel, then it will gives the 1 by R, 1 by R. Okay, and now if you want to draw this reciprocal of resistance is also called as G, where G is the conductance. Okay, we will discuss about this conductance later, right? And the slope of IV graph indicates the 1 by resistance. Okay, and for example VI graph, what we are doing it here? It was very simple. In this, I is taken on x-axis and the V is taken on y-axis, and if you get a straight line like this, and now this is the angle theta, and now here what happening? What is the difference at here? In this case we are taking the I is on x-axis and V on y-axis. In this case what we are telling? What we are taking? V on x-axis and I on y-axis. And let us see. And here if you want to find out the tan theta, what you will get? The slope is equal to tan theta, slope of VI graph, slope of VI graph, what it will gives, that is the formula is tan theta. Then the tan theta equal formula is what? Opposite side by adjacent side. This opposite side what it will gives? Okay, you take this as opposite, some point you take like this, some point you take, this indicates some voltage and this indicates some current, right? And the tan theta equal we get as V by I, right? Tan theta equal V by I. V by I is nothing but R, right? V by I is the R according to Ohm's law. That means it will give the resistance. Okay, you must remember that. Sometimes, okay, they may give the VI graph, but for this also they will give it as VI graph. Okay, but just you have to check on x-axis what is there, on y-axis what is there, right? Based on that the slope will changes. When x-axis V, y-axis I, the slope is 1 by R. When x-axis I, y-axis V, the slope is y by x. Slope is y by x. Y is V by I. V by I gives the R, right? That means slope of VI graph gives the resistance. Okay, and let us see one example. Before going to the example, I will tell about the non-ohmic substances, right? These are the ohmic substances. Next one is non-ohmic substances. Okay, listen very carefully, right? And what is non-ohmic substances? Non-ohmic substances. Non-ohmic substances. Non-ohmic substances means they will not obey the Ohm's law, right? And the definition is the substances which do not obey Ohm's law. Okay, the substances which do not obey Ohm's law are called as non-ohmic substances. Non-ohmic substances. In case of non-ohmic substances, you will not get the graph as a straight line. Why we got this as here the graph is straight line? Because here the V proportional to I. When I is increases, V is increases linearly. Here the Ohm's law is obeyed. That means V is equal to IR. V is equal to IR is nothing but it is just like Y is equal to mx. Y equal to mx. Y is equal to mx is a straight line. You will get the straight line. But if any substances, if they will not obey the Ohm's law, then for that VI graph is not a straight line, right? And for this non-ohmic substances example for components. Okay, for example, the example semiconductors, right? Semiconductor materials, they will not obey the Ohm's law. That is germanium or silicon. Okay, and for example, if you take the diode characteristics, if you take the diode, in case of diode, VI graph, how you will get? Okay, for example, PN junction diode I am taking. If you take the PN junction diode, what is PN junction diode? You know about these diodes later. In the semiconductor chapter we will learn. But if you take the PN junction diode and if you draw the VI graph, what you will get? V is taken on x-axis, I is taken on y-axis. We will get the graph like this. We will not get the graph as straight line. Okay, you will get the graph as curve. VI graph is a curve. Okay, that means it will not obey the Ohm's law. Okay, semiconductor components are the non-ohmic substances. They will not obey the Ohm's law. And what is Ohm's law? Once tell me. At constant temperature, the potential current through a conductor is directly proportional to the potential. Okay, and some more example I will tell. The gallium arsenic also does not obey the gallium arsenic. It will also does not obey the Ohm's law. For example, if we draw the VI graph for the gallium arsenic, how you will get? VI graph for gallium arsenic substance. Gallium arsenic. Okay, gallium arsenic, GaAs. And how you will get the VI graph? Let us take V on x-axis and I on y-axis. The graph we will get like this. We will get the graph like this, and here there are some regions are there. Okay, and now that regions we will modify it here. Let us say VH is taken on x-axis and IV will take on y-axis. If we indicate some regions, okay, and up to this region, and this we will take split. We will not get exactly straight line, we will get some curve here. And this is the graph. You have to remember the graph. How you will get the graph means it is a practical format. Okay, we will get the graph by the gallium arsenic. We will connect the battery and we will increase the voltage and we will note the current and we will draw the values. And in this case, this is the non-linear region. We will tell this as non-linear region. Linear means straight line, but here we are not getting the straight line, that's why non-linear region. But this is said to be negative resistance region. What is negative resistance? I will tell later. Okay, next topic is there. Negative resistance region. In one time in exam they asked the one mark question, right? Draw the VI graph for the gallium arsenic and indicate the non-linear and negative resistance region. This region is the negative resistance region and this region is the non-linear region. Non-linear means it is a curve. Negative resistance means I will tell now. Okay, no problem. When the voltage is increases, here the graph is going down, means current is decreasing. Current is decreasing. When voltage increases, the current decreases it here. Current decreases means resistance increases, right? And now generally what we say is when voltage increases, current also increases, but here it is reverse will be there, right? When voltage increases from here, it is going down. When you go to right side, voltage increases, but the graph is going down, means current is decreases, and that is said to be negative resistance region. And now what is resistance? On what factors the resistance depends, and that we will discuss. That also there in the 10th class, right? If any substance obeys the Ohm's law, for that VI graph is a straight line. If any substance does not obey the Ohm's law, for that VI graph is a curve. That you should remember, right? If any substance does not obey the Ohm's law, for that VI graph is a curve, not a straight line, right? VI graph is a curve. Here VI graph is a curve. Here also VI graph is a curve. And let us see. What is resistance? What is resistance? Can you tell what is resistance? Okay. On what factors the resistance depends? Resistance. Resistance is the capital R, right? Resistance denoted with the capital R. The property of a conductor. The property of a conductor which opposes the flow of electrons or the flow of current. Okay, the property of material or the property of conductor which opposes the flow of electrons is called as resistance. Resist means oppose the motion of electrons. Okay, is called as resistance. Now the symbol of resistor. The symbol of resistor. Okay, symbol of resistor. What is a resistor? Resistor is a device which has the resistance. This is a resistor. symbol. It's a resistor with fixed resistance. Okay, resistor with fixed resistance. Opposition is fixed for this. Now, for example, like this there, right, like this there, and this is the variable resistor, right, resistor with variable resistance, resistor with a variable resistance. And sometimes we will use like this also, that is said to be rheostat. This is also variable resistor, this is also to be rheostat. Rheostat, okay, rheostat. Rheostat is nothing but variable resistor. Rheostat is nothing but variable resistor. This is a resistance. The resistance is the property of conductor which opposes the flow of electrons. Some materials oppose the motion of electrons less, some materials oppose more, right? For example, if you take the wood, right, in that free electrons are not there. That means electron movement is opposite completely. It has infinite resistance, right? And different materials have the different resistances. The resistance is nothing but opposition for the flow of electrons, opposition for the flow of current. Flow of electrons opposite means flow of current also opposite. And on what factors this resistance depends, right? This is a 10th class syllabus, but it is also there in the 12th class, and it is useful for the further topics. Okay, after completing the resistance topic, I will close today's lecture. Okay, and now let us see on what factors resistance depends. Factors on which resistance depends. Factors on which resistance depends. On what factors the resistance of a material depends, right? You know already from your basics. And first factor is, here one more thing I will tell. What is resistance we discussed? What is its unit also we will discuss, right? Formula and unit also we will discuss. Formula is what for the resistance? According to Ohm's law we write, it is a ratio between the potential difference and current. This is the formula. And SI unit of resistance, SI unit of resistance, right? SI unit of resistance. What is the SI unit of resistance? It is ohm. Okay, its symbol is omega. Okay, this is also symbol. Okay, and now 1 ohm is equal to, we write here from this, 1 ohm is equal to, we write as 1 ohm, we write as 1 volt by 1 ampere, right? 1 volt by 1 ampere. 1 R1 V1 I1, 1 equal to 1. That means 1 ohm, 1 volt, 1 ampere. Let us see now resistances. Factors on which the resistance depends. Resistance of a conductor, of a material, depends upon, resistance depends upon, first, resistance depends upon nature of material, right? First point is nature of material. Different materials have the different resistances. Aluminum has different resistance, copper has different resistance, manganese has different resistance. Different resistors have the different resistances. Different materials have the different resistors. And resistance also depends upon the resistance depends upon dimensions of conductor. Resistance depends upon dimensions of conductor. What are the dimensions? Resistance depends upon the length and area of cross section. On these factors resistance will depends, length and area of cross section. Okay, and the third point is that resistance also depends upon the temperature. Resistance depends upon temperature. these are the factors on which the resistance depends. Okay, resistance depends upon the nature of material, resistance depends upon the dimensions, resistance depends upon the temperature. Now how the resistance depends upon dimensions, let us discuss. Resistance is directly proportional to the length of conductor, right? Resistance is directly proportional to the length of conductor, that is R proportional to L, and the resistance is directly proportional to length. This is equation 1. Okay, and one more factor, how the resistance depends upon the area. Here directly proportional means what? If length is more, then the R is more. The wire which have more length, it has more resistance, and the wire which has less length, it has less resistance. And resistance is inversely proportional to the area of cross section. Okay, area of cross section of conductor. That means resistance inversely proportional to area of cross section means 1 by A we write. This is equation 2. Okay, and the next, when we combine these two, right, the equation 1 and equation 2, what you will get? Here the equation 2 is resistance inversely proportional to area. Okay, and this is equation 2. What are the factors? First factor is length. If length is more, the resistance is more. This is the length. If the length is more, then the resistance is more. Second factor is area, right? Area. This is the area, cross sectional area. Cross sectional area shape is circle for the wire. That circle area is pi r square. Okay, circle radius is pi r square. Cross section is in circle shape. Okay, and let us see, when we combine the two, what you will get from equation 1 and 2. From equation 1 and equation 2, what you will get? R proportional to L and R proportional to 1 by A. When we combine these two, we will get R proportional to L by A. Okay, look at here, this is L, right? And my pronunciation also you have to listen very carefully, right? By that you know what is this letter, right? R is equal to rho L by A. When we remove the proportionality, we will get a constant, that is rho, right? What is rho at here? Rho is the proportionality constant. It is said to be resistivity or specific resistance. Specific resistance. Specific resistance. Okay, rho is the resistivity or specific resistance. In some books it may be denoted with S also, right? And now this is the formula for resistance. And now let us discuss about what is resistivity, right? What is resistivity? In this we are getting the one term, that is resistivity. The resistance formula is this one, rho equal to R equal to rho into L by A. And now what is resistivity and what is its unit? Resistivity is rho, right? Resistivity is rho. Okay, and now what is the formula for the resistivity? From this we will get resistivity as RA by L. Is it right? Rho is equal to RA by L. A we will take left side, L we will take left side, then we will get this one. If you take a Li is 1 unit and A is 1 unit, then what you will get? The rho. Rho is equal to R, right? Rho is equal to R into 1 by 1. Then rho is equal to R you will get, means resistance is equal to resistivity when resistance per unit length per unit area. Resistance per unit length, resistance per unit length and per unit area of cross section. Area of cross section is called as is called as resistivity or specific resistance. Resistivity or, tell me what is that? Specific resistance. What is the definition? Resistance per unit length per unit area. What is the formula for the resistivity? Resistivity formula is rho is equal to, from this we take A to left side, R into A by L to left side, RA by L, right? This is the formula for the resistivity. What is the SI unit of resistivity, right? SI unit. And before SI unit, if Li will take as 1 and Ai will take as 1, then what happens? If L is equal to 1 unit and A is equal to 1 unit, then rho is equal to R into 1 by 1, that is rho is equal to R. Resistivity is equal to resistance. When means resistance 1 unit length 1 unit area, resistance per unit length per unit area is equal to resistivity. And what is the SI unit of resistivity, right? SI unit of rho. Can you tell SI unit from the formula? For every physical quantity, from the formula we may write the unit. Resistance unit is ohm, area unit is length into breadth meter square, by length unit is meter, then we will get ohm meter, right? The SI unit is ohm meter, right? Ohm meter, ohm meter, ohm meter, right? And now on what factors the resistivity depends? Resistance depends upon what? Nature of material. Resistance depends upon nature of material, dimensions of material means length and area, and also depends upon the temperature. Now let us see on what factors the resistivity depends. How the resistance depends upon temperature, that also we will discuss step by step, okay? And if you have any doubt, you can also comment, right, in YouTube. And now let us see the factors on which resistivity depends. On what factors the resistivity depends? Resistivity also depends upon nature of material, and resistivity depends upon temperature, but the resistivity is independent of dimensions of material. And resistivity does not depend upon dimensions. Let us see factors on which resistivity depends. Factors on which resistivity depends. Resistivity depends. On what factors the resistivity depends? Okay, very simple, and everything you learned in the 10th class, right? And the next session onwards, this will not there, okay? And now factors on which resistivity depends. The first point is resistivity depends upon nature of material. Resistivity depends upon nature of material. And the next, resistivity or the specific resistance depends upon temperature. Okay, right? There is one topic is there, temperature dependence of resistivity or resistance. In that we discussed how resistance and resistivity depends upon temperature. Okay, and let us see, resistivity depends upon nature of material and resistivity depends upon temperature. The note point, there is important note point. The note point is that the resistivity independent of dimensions of material. Resistivity is independent, means it does not depends, independent of dimensions of material. Dimensions of material means resistivity does not depends upon length and area, okay? Why it will not depends upon the length and area? When length increases, resistance increases. When area increases, resistance decreases. Then resistance depends upon the length and area. This resistivity is just like a density. For example, mass proportional to volume. Okay, mass proportional to volume or volume proportional to mass. When the volume increases, mass increases. When mass increases, volume increases, right? And when the proportionality is removed, we will get a term, that is, when the proportionality is removed, we will get a term constant, that is rho v. This is the density. Density equal to mass by volume. This density depends upon the nature of material, but it does not depends upon the mass and volume, right? And because when mass changes, volume also changes. It is the property of material, only it depends upon the property. Okay, remember that. Just like it is a density, okay, and it depends upon only nature of material and independent of dimensions of material. And this is factors on which resistivity depends. And the next topic is conductance. What is conductance? Conductance denoted with capital G. Conductance is the reciprocal of resistance. What is the definition? The reciprocal of resistance. The reciprocal of resistance is called as conductance. Conductance is what? It is the reciprocal of resistance. That means conductance is equal to 1 by resistance. The material which have less resistance, it has more conductance, right? More current passes. Resistance less means opposition less for the current. When opposition is less, then current flows more amount of current flows. That means conductance is more. And SI unit of conductance. SI unit of conductance 1 by ohm, right? Or ohm inverse, right? This ohm inverse is also called as Siemens, or it is also called as mho or Siemens. Okay, ohm inverse or Siemens or mho, it is a unit of conductance. And the next topic is conductivity. What is conductivity? Let us see what is conductivity. You know already, right? Tell me, what is conductivity? Conductivity is denoted with sigma. It is the reciprocal of resistivity, right? The reciprocal of resistivity. The reciprocal of resistivity. The reciprocal of resistivity is called as conductivity. Okay, reciprocal of resistivity is called as conductivity. Conductivity is equal to 1 by resistivity. 1 by resistivity. Reciprocal means 1 by. 1 by resistivity is called as conductivity. But conductivity denoted with sigma. Sigma is equal to, we have 1 by rho. But rho formula we know, right? What is the rho formula? Rho is equal to RA by L, right? And 1 by rho, it is a reciprocal. Then we will get L by RA, right? This is the conductivity. And its SI unit I am going to tell. What is the SI unit of conductivity? SI unit of conductivity. SI unit of conductivity is the 1 by resistivity, means 1 by ohm meter, or 1 by ohm is mho per meter, right? Or 1 by ohm is also said to be Siemens per meter. Siemens per meter. Okay, and this is the conductivity. Conductivity is the reciprocal of resistivity. Conductance is the reciprocal of resistance. And the next one is one small note I will tell, and after that I will close today's topic. Note: if a wire stretched without change in its volume, without change in its volume, in this moment how the resistance depends on various factors. Let us see. This is a wire, right? It has some length L. What I did now, I elongated this one, right? This is the area. When you will elongate this one, when you will stretch this one, what happens? Its area is decreased, right? Area decreased, but the length increased, right? Length increased. Just I am stretching this one. I am stretching. This is before stretching. L1 A1, after stretching L2 A2. This is before stretching, and this is after stretching a wire. After stretching a wire. Now in this case, how resistance depends and how resistance will changes. Here the resistance is R1 and here the resistance is R2. In this case, how the resistance will depends. When we stretch this one, what happening? Length is increasing but cross section is decreasing. When we stretch like this, length is increasing, but area is decreasing. Means the product of length and area is constant. What is the product of length and area? It is a volume. Volume is constant. In case of stretching, volume does not changes. Right? Only length increases and area decreases. It will become more thin and thin and thin. In this case, we know formula, right? We know what is the resistance, right? Resistance formula is rho is L by A. That means this is the formula we know already. Okay, and it has some material. It is made with some material. After stretching, the material does not changes. That means rho does not change. Rho depends upon the material, right? Then this we will multiply with with L and divide with L. Then we will get rho L square by area into length. This A into L gives the volume, right? Volume of wire. Volume of wire constant, resistivity constant, means resistance proportional to square of length. This is only for in case of stretching. If you will stretch any wire at that moment, okay, during stretching, right? Resistance proportional to square of length. When you will stretch any object, at that moment resistance proportional to square of length we will use. Or otherwise, in terms of area, if you want to write, we know that resistance is equal to rho L by A. Now what I did here, I multiply with A and divide with A. In previous case, what I did? Multiply with L and divide with L. And rho into L into area. Length into area gives volume by area into area square. Hence resistance inversely proportional to square of area, right? These two we will use when we will stretch a wire. Okay. For example, one question I will tell. A wire of resistance 3 ohm. It is stretched to reduce its radius by 1/4 times. Reduced to 1/4 times. Then what is its new resistance? Okay, one question I will tell. Okay. I will write the question first. Okay, look at here. This is our question. What is our question? A piece of aluminum wire is stretched. A piece of aluminum wire is stretched to reduce its diameter to half of its original value. Then find its resistance. New resistance. What happening it here? This is a wire. It has some length L1 and it has some diameter, that is initial diameter is, okay, initial diameter is D. And what happened? It is stretched now. It is stretched. When it is stretched in such a way that its diameter become half of its original value. That length how many times it will becomes we don't know, but only they gave the diameter reduces to half of its original resistance, original value. And its initial resistance they gave as a piece of aluminum wire is stretched to reduce diameter and its new resistance. Okay, for example, the original resistance we can consider as R. What is the new resistance? That is R2 is what? What happens to the new resistance? Look at here, in this case, here we are stretching, right? We are stretching it here. The initial radius is we can consider as R. When diameter become half means radius also becomes halves. And initial resistance we will take as R. And the final radius is half of initial radius. But the final resistance is what? That is our question. What happens to the resistance? Okay, then what happens to its resistance? We can write like this. Instead of finding the new resistance, we will ask then what happens to new resistance? Then what happens to its resistance? Okay, what happens to its resistance? What happens to its resistance? Okay, whether it decreases or increases, then how many times increases? Let us see here. In this case, while stretching, okay, while stretching we use the formula, right? Here diameter half means radius also half. Initial resistance we are taking R, and final resistance what happens? Then resistance proportional to 1 by area square in case of stretching. But area is what? Area is pi r square, right? Pi r square whole square we write. Here pi square we write r power 4. Then we write resistance proportional to pi square r power 4. But pi square is a constant, means resistance is inversely proportional to r power 4 we write, right? And now resistance R1 by R2, if you want to write ratio form, this is numerator, 1 by 2 we have to write. This is the denominator, we have to write 2 by 1, R2 by R1 whole power 4. R1 by R2, R1 is R, R2 we have to find out. Final radius is R by 2, initial radius is R whole square. Then after simplifying this we will get, this is power 4, 1 by 2 power 4, right? Then R by R2 is equal, what you will get? This is equal to 1 by 16. This is nothing but, what you will get? R by R2 is 1 by 16. From this, R2 is equal to 16R. That means when radius decreases to half, then its resistance become 16 times. Resistance becomes 16 times. Increases by 16 times, right? Increases by 16 times. Resistance becomes 16 times of original or initial resistance. Okay, this is today's lecture. Thank you for watching my lectures. Till now, if you not subscribed my channel, then press the subscribe button and bell icon, right? And share to your friends. And already we completed the 2 chapters, electric charges and fields and electrostatic potential and capacitance. And electric charges and fields have 16 videos and potential and capacitance has 13 videos, 13 lectures. You can also watch again, okay, revise them and complete the notes and prepare properly. If you will get any doubt, you can comment, okay, and you can also give some suggestions in the comment and what you want, what changes you want. Thank you for watching my lectures.